Hello friends, I am Balaji Rao. Welcome to BR Max class. This is third class on determinants. Till now we did 10 problems in this determinants. In this class we are going to do another 5 problems. You see this question, we need to show that the value of this determinant is 1 plus a square plus b square whole cube. Compared to all other problems what we did till now, this problem is a difficult one. Let's see how to solve this problem. First, I'll consider LHS part of this question. You see, I considered LHS of the given question. By seeing this question, we won't get any idea immediately. That is the problem. Throughout this problem, I am going to use only one operation. Let's see what is that operation. See here, R1 changes as R1 plus BR3. Actually, how you will get an idea to apply this operation? Initially, when you do this problem first time, you won't get this idea. This is one of the typical problem in exercise number 4.2. Why I chosen this operation? Change is there in R1. I'll apply this operation. Let's see what happens. R1 changes as R1 plus BR3. R1 is what? 1 plus a square minus b square. R1 plus, see this plus I written here, BR3. That means b into R3. b into 2b is what? That is 2b square. Okay. So what happens here? You see 1 plus a square minus b square plus 2b square. Minus b square plus 2b square is plus v square. So if I simplify this, what I'll get? I'll get 1 plus a square plus b square. Now let's see for this element. R1 is 2ab, okay, plus b into R3. This element you multiply with b. When you multiply this element with b, this will become minus 2ab. See, 2ab minus 2ab is 0. So you will get 0 here. You see for this element R1 is what? Minus 2b plus, this plus is then I written plus, BR3. That means this element you multiply with b. This element you multiply with b, what you will get? 1 into b is b minus b into this element is ba square minus b into this element is b cube. Now I'll simplify this little bit. Minus 2b plus b is minus b. Okay, minus ba square minus b cube. What I'll do, in this I'll take minus b common. Let's see what happens. You take minus b common, what you will get? 1 plus a square plus b square. So in this, if you take minus b common, you will get like this. Minus b into 1 plus a square plus b square. I think maybe you got an idea why I chosen this operation. You see here, I got 1 plus a square plus b square. You see here, I got 1 plus a square plus b square. Because of this reason only, I chosen this operation. I am going to apply one more operation immediately here only. You need to memorize that operation. What is that operation? You see, the operation is this one. R2 changes as R2 minus AR3. Throughout this problem, only these operations. Rest of all, everything is easy. To do this problem, what you need to do is, you need to memorize these operations. Okay? Right. I'll apply this operation. Let's see what happens. R2 is what? 2ab. 2ab minus a into R3. That means this element you multiply with a. A into 2b is 2ab. Okay? So 2ab minus 2ab is 0. So you will get 0 here. Okay? Now you see this element. This element is 1 minus a square plus b square minus a into this element. A into this element is minus 2a square. You can understand. A into this element. A into minus 2a is minus 2a square. Simplify this little bit. What you will get? See, this is minus a square. This is minus of minus plus. Minus a square plus 2a square is plus a square plus b square. So, when I apply this operation, what I am getting here? I am getting 1 plus a square plus b square. So, I written 1 plus a square plus b square. Okay. Now, you apply for this R2. R2 is what? 2a minus this element you multiply with a. Here minus is there. Multiply this element with a. What you will get? a minus a cube minus ab square. You got like this. Do this little bit of simplification. 2a minus a, that is a minus of minus plus a cube plus ab square. You observe here, I can take a common from this. You take a common. If you take a common, what you will get? 1 plus a square plus b square. So when I apply this operation, this element changes like this. A into 1 plus a square plus b square. I hope you are understanding. You observe here, by this time you will get an idea why I chosen this operation. See here, 1 plus a square plus b square, 1 plus a square plus b square. So it is important you need to memorize these operations. Once you memorize these operations, this problem is nothing. Rest of all we will get very easily. Now, any changes there in R3? No changes there in R3. So I'll write R3 as it is. Do not worry, from now onwards everything is going to be easy. You observe the first row. Here 1 plus a square plus b square is there. Here also 1 plus a square plus b square is there. This 0 is there. 0 means I can imagine it as 0 into 1 plus a square plus b square. So what I can do, from this first row, I can take 1 plus a square plus b square common. So I am taking that common. You observe the second row. In the second row, here 1 plus a square plus b square is there. Here also 1 plus a square plus b square is there. Here also 0 into 1 plus a square plus b square will be there. So what I can do, from the second row, I can take 1 plus a square plus b square common. So from the second row you take that common. Here already 1 plus a square plus b square is there now. So what happens, this will become 1 plus a square plus b square whole square into determinant of. When I take 1 plus a square plus b square common from the first row, what are the remaining? Here 1, here 0, here minus b. Now you see the things are becoming simpler now. From the second row, you take in 1 plus a square plus b square common now. So what are remaining? 0, here 1, here a. Third row as it is. You observe here, further what to do? Whatever the operation I'll apply here, it is not going to be simplified. So what I'll do, I'll expand this determinant. Let's see what happens. I written 1 plus a square plus b square whole square as it is. Now I am going to expand this determinant. You know how to expand the determinant. 1 into, delete this row and this column, determinant of this part, right? 1 into this expression is this expression only. You see how to expand this determinant of 2 by 2 matrix. 1 into this element minus this element into this element. 1 into this element is what? I'll write 1 into this element is 1 minus a square minus b square. Okay, minus 2a into a. Minus 2a into a is minus 2a square. Minus 2a square plus minus b into, now determinant of this part. See, delete this row and this column, determinant of this part. 0 into minus 2a is 0. 0 minus, you see here 2b into 1. 2b into 1 is 2b. Okay, right. Let's simplify this further. We'll see what happened. 1 plus a square plus b square whole square into. Okay, now you see here 1 minus a square minus b square minus of minus plus 2a square. See here, this is minus 2b, this is minus b. Multiply both, what you will get? You will get plus 2b square. Plus 2b square. Okay, see, let's see what happens. 1 plus a square plus b square whole square into. See here, 1 minus a square plus 2a square. Minus a square plus 2a square is plus a square. Minus b square plus 2b square is plus b square. Okay. So you see here 1 plus a square plus b square whole square. Here 1 plus a square plus b square is there. You multiply both, what you will get? You will get 1 plus a square plus b square whole cube. See, this is the required RHS. We started with LHS and we got RHS, right? Now we will see the next problem. You see this question number 12. We need to show that the value of this determinant is 4 times of a square, b square, c square. Compared to last problem, this problem is very easy. To do this problem, first I'll consider LHS. You observe here, I considered LHS. You observe this first row, here A is there, here A is there, here also A is there. Similarly, you observe the first column. Here also A is there, here also A is there, here also A is there. I'll take A common from the first row, or we can take A common from the first column also. I'll take A common from the first row. See, from the first row, if I take A common, what I'll get? If I take A common from the first row, what is remaining here? Minus A. If I take A common here, B is remaining. If I take A common here, C is remaining. Okay. Now you observe the second row. In the second row, here B is there, here B is there, here also B is there. So I can take B common. You take B common from the second row. So what you will get? A minus B, C. From the second row, I taken B common. Similarly, from the third row, you take C common. See, take C common, what is remaining? A. If you take C common, B is remaining. If you take C common, minus C is remaining. Okay. Now, you observe here. From the first column, can I take A common? Here A is there, here A is there, here A is there. So, from the first column, I can take A common. So, take A common. Already A is there. Na? When you take A common, it will become A square. Okay. From the second column, I'll take B common. Already B is there, na? It will become B square. From the third column, I'll take C common. Already C is there, na, here, na? When you take C here, it will become C square. Okay. As you taken A common from the first column, what will be remaining? Minus 1, 1, 1. If you take B common from the second column, what will be remaining? 1, minus 1, 1. If you take C common from the third column, what will be remaining? 1, 1, minus 1. Okay, right? Now further we need to simplify this. You can do this problem in two methods. One is by expanding the determinant, another one is by using properties of determinants. I just want to do this problem by using properties of determinants. What I will do here, I am checking that can I make this element 0 by using this element? Yes, if I add these two elements, this element will become 0. Now I am checking that is it possible to make this element 0 by using this element? Yes, if I add these two numbers, I can make this element 0. You look here, what operation I written? R2 changes as R2 plus R1. That means this element plus this element. Okay, let's see what happens when we apply this operation. This A square, B square, C square as it is. When I apply this operation, R1 no change is there. So minus 1, 1 I'll write R1 as it is. R2 change is there. All the elements of R2 are added to the corresponding elements of R1. See, add these two elements, what you will get? 0. Add these two elements, what you will get? 0. Add these two elements, what you will get? 2. 1 plus 1 is 2. Okay. Now, I want to make this element also 0. This is in which row? This is in third row. I'll write like this. R3 changes as R3. This element plus this element will become 0, right? So R3 plus R1. I'll write this operation. So change is there in R3. All the elements of R3 are added to the corresponding elements of R1. Add these two elements, what you will get? 0. Add these two elements, what you will get? 2. Add these two elements, what you will get? 0. Okay. After this step, what I'll do, I'll interchange R2 and R3. Let's see what happens after interchanging R2 and R3. See this operation, R2, R3 interchanging. Look here, when I interchange any two rows, any two columns in determinants, what happens? The determinant changes its sign. We learned this property. In a determinant, if any two rows, any two columns are interchanged, then the determinant changes its sign. As we are interchanging R2 and R3, we will get opposite sign here. Already plus is there, na? So what you will get here? Here you will get minus. Now interchange these two. See 0, 2, 0, okay. 0, 0, 2, okay. 0, 0, 2, right. Okay. See here, as I interchanged R2 and R3, this is the determinant of a triangular matrix. You see all the elements below the diagonal are 0. No? What is this? This is the determinant of a triangular matrix. We know the determinant of a triangular matrix is product of all its diagonal elements. So minus A square, B square, C square into how? What is the value of this determinant? Product of all its diagonal elements. That is minus 1 into 2 into 2. When you multiply here, minus of minus will become plus. 1 into 2 into 2 is 4. So what you will get? That is 4 times of a square, b square, c square. So this is the required RHS. What happened? We started with LHS and we got this RHS. So we proved this problem. This is very easy problem, isn't it? Now we will move to next problem. Now you observe this question. What information they given? If x, y, z are different and the determinant value equal to 0. They given the value of this determinant is 0. Then show that 1 plus xyz equal to 0. First, I'll write the given information. What is the given information in this question? The value of this determinant is 0 and they are saying that xyz are different. First, I'll take this information. They given that the value of this determinant is 0. You observe all the elements of third column. What you identified? All the elements of third column is expressed as sum of two terms. In properties of determinants, we know that in a determinant, all the elements of any row or any column is expressed as sum of two terms. Then the determinant can be expressed as sum of two determinants. Sum of two determinants like this. See here what happened. First, all ones written like this. These are all as it is. You see this part is as it is. This 1 plus x cube is there, now 1 I written here, x cube I written here. 1 plus y cube is there, now 1 I written here, y cube I written here. 1 plus z cube written like this. We know this from the properties of determinants, we can write like this. Now further, how to do this problem? I'll write this determinant as it is plus, you observe here, from the first row I can take x common. From the second row I can take y common. From the third row I can take z common. So from the first row you take x common, from the second row you take y common, from the third row you take z common. Let's see what will be remaining. If you take x common from the first row, 1 x square you will get. If you take y common from the second row, what you will get? 1. As you taken y common here, 1y remaining. As you taken y common here, y square will be remaining. If you take z common from the third row, what are remaining? 1 z square equal to 0. You observe here all the elements of first column 1 are there. So I want in this determinant also all the elements of first column 1. For that what I'll do, you observe here what I did, I interchanged C1 and C3. See, C1 and C3 I interchanged. When I interchange any two rows or any two columns, the determinant changes its sign, so minus will come here. But what is my intention? My intention is I want to make this determinant same look like this. For that 1 1 1, here also 1 1 1 is there, it's not a problem. You see here x square y square z square is there, but here x y z is there. For that purpose what I will do, again I will interchange these two columns, C2 C3 I will interchange. When I interchange C2 C3, here I will get x y z, here I will get x square y square z square. As I am interchanging two columns here, the determinant changes its sign. What you will get here? Here already minus is there now, it will become plus. See here, I hope you are understanding what I did. First I interchanged first column, third column. So 1 1 1 will come here. To get this determinant, again for the determinant, I interchanged second column, third column. As I interchanged two times, minus of minus will become plus only. Plus, remaining all as it is, I'll write. See here, rest of all I written as it is. You observe this determinant and this determinant. Both are same. 1 1 1 x y z x square y square z square. 1 1 1 x y z x square y square z square. What I can do here, I can take this determinant common because determinant is a number now. What I'll do in these two terms, I'll take this determinant common. See, if you take this determinant common, here also determinant is there, here also determinant is there. If you take this determinant common, what you will get? 1 you will get from here, 1 xyz you will get here. See, 1 plus xyz into this determinant. Okay. Further, how to do this problem? If you want, you can do little bit lengthy or else you can finish it very quickly. This type of problem we did in question number 1, I think in question number 1 or 2, I did the same problem. What I'll do here after this step, you observe all the elements of first column are 1, I'll make this one 0 and I'll make this one 0. Further, I'll do this problem. Or else, I know the answer for this as I did this problem in the second question. I'll write it answer directly. You can write like this in exam also. You will get full marks. Nothing to worry about it. See what I'll do here. 1 plus xyz into, if you want, you just apply the operation, you make this one 0 and you make this one 0, further you do and get the answer, or else as we already did this problem, I know answer for this, I am writing this answer. In exam also you can write like this directly. Okay, when you simplify this, what you will get, answer you will get like this, x minus y into y minus z into z minus x equal to 0. Okay, what is our intention? In the question what they are asking? They are asking to show that 1 plus xyz equal to 0. For that, what information they given? They given x, y, z are different. What you got? You got product of all these terms is 0. Product of all these terms is 0 means what? It means that at least one of them must be 0. Product of all these terms is 0 means at least one of them must be 0. Yes. Here, what they mention, x, y, z are different. They given this information also. X, y, z are different means x not equal to y not equal to z. They are all different. You take y to this side, x minus y is non-zero number. You take y to this side, x minus y is what? X minus y is not equal to 0 clearly. As y is not equal to z, y minus z is also non-zero number. You take x is not equal to z, x is not equal to z, z minus x also non-zero number. What I am trying to say, product of all these terms is 0 means at least one of them must be 0. Here, whether this is 0 or not, I do not know. Okay, here this is non-zero number. No doubt this is non-zero number because they given x, y, z are different. Y minus z is also non-zero number. This is also non-zero number. So only chance is this will be 0. If this is 0, then product of all these terms will be 0. Otherwise, no chance that product of all these terms are 0. I hope you are understanding. As this is non-zero number, this is non-zero number, this is also non-zero number. As their product is 0, only chance is there, this will be equal to 0. Therefore, 1 plus xyz equal to 0. I hope you understand this. Now, we will move to next question. You observe this question. We need to prove that the value of this determinant is 4 times of ABC. This is not very easy problem because you don't get any idea how to do this problem by seeing the question. However, we can do this very easily. Let's see its solution. First, I will consider LHS. I considered LHS first. I need to prove that the value of this determinant is 4 times of ABC. By saying this question, here B plus C is there, here B is there, here C is there. So what I'll do, I'll use this operation. See, R1 changes as R1. R1 means B plus C. Now I'll subtract B and C so that this element will become 0. Minus R2 minus R3. Initially, other than this, you don't get much idea how to simplify this, how much thinking you do, how many operations you do. You cannot simplify better than this. Okay, so what I'll do here, I'm going to apply this operation. See, let's see what happens. Determinant of change is there in R1. R1 changes as R1. R1 is what? B plus C. R2 minus R2 is what? B. R3 is what? R3 is C. See, plus B minus B plus C minus C will get cancelled. This element will become 0. Now, you see for this element what happens? R1 is A minus R2 is C plus A minus R3 is C. See here what things will get cancelled. This plus A minus A will get cancelled. Here minus C will be minus 2C. So what you will get here? You will get minus 2C here. Now apply this operation. A minus B minus of A plus B. See here plus A minus A will get cancelled. Minus B is minus 2B. You will get minus 2B here. Okay, rest of all as it is I will write. After this step, whatever the operations we are applying, still it is becoming complicated. So best thing is you expand this determinant at this point. You expand this determinant. See here 0 into this 2 by 2 matrix determinant is 0 only because 0 into this determinant is 0. That's why I will write 0 here. Minus, what is there here? Minus 2C. Minus 2C into, now delete this row and this column. Determinant of this part. Determinant of this part. I hope you are understanding how to calculate. B into this element minus this element into this element. B into this element. See here. B into this element is what? It is AB plus B square minus this element into this element, that is BC. Okay, so plus I am just expanding this determinant, plus minus 2B into, now determinant of this part, BC minus, multiply these two, what you will get? Minus of C square plus AC. I hope you are understanding. Now I'll simplify this further. Let's see what happens. This minus of minus plus. This is 2C. Now multiply 2C into all these elements. What you will get? This is 2ABC plus 2B square C. This is plus 2C now. 2C into this element, that is 2C into B square, minus 2BC square. Okay. Now plus of minus minus. See here. Plus of minus is minus. First I'll write minus. Now multiply each element of this with 2b. Multiply, what you will get? You will get 2b square c minus 2b c square minus 2abc. You will get like this. If you multiply this whole expression with 2b, you will get like this. Now you see any terms will get cancelled. Here you see plus 2b square c. Here plus of minus is minus. Minus 2b square c will get cancelled. Now here 2bc square is there. This is minus 2bc square. Here minus of minus will become plus. So this term also will get cancelled. Now what is remaining here? This minus of minus is what? Minus of minus is plus. Here 2abc is there. Here minus of minus plus 2abc. 2abc plus 2abc is what? That is 4abc. So we got RHS here. Therefore we proved that the value of this determinant is 4 times of abc. I hope you understand this. This is a last question in this class. We need to show that the value of this determinant is ABC into 1 plus 1 by A plus 1 by B plus 1 by C, and we need to show that this equal to ABC plus BC plus CA plus AB. From here to here, proving is very easy. Only the main part is we need to show that the value of this determinant equal to this expression. First, I'll consider LHS. You observe here, first I considered LHS, right? In the answer, you see in the beginning ABC is there. Na? So what idea I got? I'll take A common from the first row. Initially, by seeing this question, you don't get that idea. But here in the answer, ABC into is there. So what I'll do to get this ABC, first I'll take A common from the first row. When you take A common from the first row, what you will get? From this expression, if you take A common, you will get like this, 1 by A plus 1. If you take A common here, you will get 1 by A, because A into 1 by A is 1. If you take A common from this, you will get 1 by A. I hope you are understanding. From the second row, I'll take B common. If I take B common from the second row, what I'll get? I'll get 1 by B, because B into 1 by B is 1 only. From this, if you take B common, what you will get? You will get like this, 1 by B plus 1. From this, if you take B common, you will get 1 by B. I hope you are understanding. From this third row, I'll take C common. Then what I'll get? Here I'll get 1 by C. Here also I'll get 1 by C. When you take C common, what you will get here? 1 by C plus 1. In the answer, 1 plus 1 by A plus 1 by B plus 1 by C is there. You observe this row wise, 1 plus 1 by A plus 1 by B plus 1 by C, 1 plus 1 by A plus 1 by B plus 1 by C, 1 plus 1 by A plus 1 by B plus 1 by C. What idea you got here? You must and should get this idea that when I add R1 plus R2 plus R3, all the elements, corresponding elements, I am getting 1 plus 1 by A plus 1 by B plus 1 by C. So further we can do this problem very easily. R1 changes here, na? Apply this operation. What you will get? You will get R1, you will get like this, 1 plus 1 by A plus 1 by B plus 1 by C. Here also what you will get? 1 plus 1 by A plus 1 by B plus 1 by C. See, all the elements of R1 you will get like this, 1 plus 1 by A plus 1 by B plus 1 by C. You will get like this. R2, R3 no changes there. So R2, R3 I'll write as it is. Now from the first row I'll take 1 plus 1 by A plus 1 by B plus 1 by C common. So as I take 1 plus 1 by A plus 1 by B plus 1 by C common, all the elements of first row will become 1 like this. See here, 1, 1, 1. Rest of all are as it is. Now from the beginning of the first class we are saying that in a determinant, if we saw all the elements of any row or any column are 1, feel happy because we can do that problem very easily. Here, how you will do further? I will make this one 0 by using this one. This is in which column? This is in second column. This is in which column? This is in first column. So what I will write here? I will write operation like this. C2 changes as C2 minus C1. okay, to make this element 0. Now I'll make this element 0 by using this element. This is in which column? This is in third column. This is in first column. So C3 changes as C3 minus C1. I am going to apply these operations. Let's see what happens. ABC into 1 plus 1 by A plus 1 by B plus 1 by C are written as it is. Now apply this operation. No change in C1. So 1 by B, 1 by C. Okay, C2 changes na, this element minus this element, 1 minus 1 is 0, C2 minus C1, see this element minus this element, 1 plus B plus 1 minus 1 by B plus 1 by B minus 1 by B will get cancelled, you will get 1 here. Okay, now 1 by C minus 1 by C is 0, I hope you are understanding, right? Now this operation, C3 minus C1, 1 minus 1 is 0, okay. 1 by B minus 1 by B, that is 0. Now this element minus this element minus this element is 1. So you got here. Now you see this is very easy from here onwards. First I'll write this ABC into 1 plus 1 by A plus 1 by B plus 1 by C into. You observe this is the determinant of a triangular matrix. All the elements above the diagonal are 0. This is the determinant of a triangular matrix. What is the determinant of a triangular matrix? Product of all its diagonal elements. So 1 into 1 into 1. So its determinant is 1 into 1 into 1, that is nothing but 1 only. So you got that expression. This into 1 is this expression only. No need to write this. So you got this. Now further to get this expression, ABC into 1. Multiply these two. ABC into 1 is ABC plus ABC divided by A. See here, ABC divided by A. What happened? AA will get cancelled, you will get BC plus ABC into 1 by B, BB will get cancelled, you will get AC. ABC into 1 by C, CC will get cancelled, you will get AB. So we got this expression also. Dear friends, this is all about practice. Practice makes man perfect. The problems and properties of determinants, little tough. Many students feel it is difficult because they do not know how to start the problem. But if you follow what order I said from question number 1 to question number 15, once you completed all these 15 problems, then you are ready to do any problems on properties of determinants. If you like this video, please drop like, because making videos is not an easy. It is taking so much of time, and share this video with your friends. Thanks for watching this video. Have a great day. Bye-bye.